Hello and welcome everybody to my channel. Today we're gonna discuss about how to do or how to compute a box plot along with this ANOVA result. That means the p-values, even the level of significance, and also addition of a jitter and displaying the mean value as well as the number of sample together with significance letter or the mean separation using our software. So many people are requesting me to my channel as well as to my email. So I hope this will be my last tutorial regarding to Boxplot related issue. So the first step is just remove anything that found in the brain of R using the RMM function. So you can do in this way. Then let's import my data. In fact, it's our data which is found in the desktop. Yeah. Yes, desktop, and the data name is raw data. Yes, this is my data, which is randomized complete block design with 3 replication, and the trail is on different fertilizer rate on wheat grain yield performance. Then the first step is as you can see, raw data is too long, so let's shorten by assigning to k. So by now our data name will be k. Then immediately you have to change the factor. For example, in our case the factor is fertilizer, so we have to convert in this way. Again, also do in the same way for the replication. Then immediately we can create the box plot using the ggboxplot function, then followed by k means our data name. So you have to follow by your data name. Then you have to assign the x-axis to the factor. So in our case the factor is a fertilizer, so I assigned here in this way. Then the y will take the response variable that you are going to measure. So for this tutorial is grain yield is the y-axis or the response variable, and the color is depend on the number of fertilizers or depend on the number of treatment that you have. So in our case we have 8 treatments, so I am expecting, or we're expecting to have 8 box plot, or you can do by your own using the fill function. So you have to refer one of my tutorial, or later I will show you how to fill or how to give the color by ourselves. Then if you want to add a jitter, so you have to add is equals to another quotation, you have to use the jitter. Then if you don't want the legend, so you have to say legend is equals to none. Then sometimes the treatments maybe it's too long, so you may just rotate to some angle. So using the rotate text, then you have to specify the angle that you want to rotate the x-axis levels. Again, also you have to use stat compare means function, which is help us to calculate the ANOVA as well as displaying the p-value and the level of significance. So level dot y means to display the ANOVA, that means the p-value in the y-axis at the point of 7. Then that's depend on your data. For example, if grain yield is 70,000, so you have to assign into 70,000. But I checked my data. My data is contained to the maximum of 5 point something. So I assigned the p-value at the y-axis at the point of 7. Then in similar fashion, stat compare dot means, that means the level of significance. Level of significance is maybe it is ns, maybe it is 1 asterisk, maybe it's 2 asterisks or 3 asterisks. So if you want to display that asterisk, so you have to use the stat compare means, then again the significant, then method is equals to ANOVA, then the level dot y means at the position of y in which you are going to display the significance result, because the p significant it means asterisk or it is ns, so it will display some point at the y value around 6.6. So type this and submit to RStudio. Then sorry, yes, we forget to submit this package. I hope now it will be work. Yes, let's run. Yeah, let's see our box plot. Yes. So as you can see here, the ANOVA, means the p-value, is displayed around 7, and while the significance value it is around 6.6. So by this way you can arrange, and again we have treatment 1 and end with treatment 8 with a different color along with jitter. So by now we'll add the significance letter or the mean separation using the AB letters. So we will display this on this, and on this box plot then we will use the Take honest significance difference, because the p-value is which is 0.00068, which is statistically significant. So if the ANOVA is significant, we have to go for the mean separation technique. So there are a number of mean separation technique, as all of you know that. So I select the one that means the honest significance test, which is built in the Agricola package. So don't forget to run or to submit the Agricola package in this way. Then after, you have to create the maximum value using our data and connect through a pipe, and the group is by our factors. So in our case, our factor is fertilizer or fur. Then the maximum value that we are going to analyze is granule. So type this and submit to our studio. As you can see here, the summarize function is not available, so you have to go for the player, go for this and this package. So this will help you to get the maximum value. So type this and submit to our studio. Then let's see our value. Yes, then again we have to do for the honest significance difference using the hsd.test, then analysis of variance, then this followed by the response variable. So the response variable in our case is a granule, then it is followed by fertilizer plus replication, since our design is randomized complete block design. Then our data name is K, so show in this way. Then again the treatment is the fertilizer, then the group is equal to true. So type this and submit to our studio. Then again we have to arrange the significance later. Yes, here is the significance later. So the highest granule according to the honest significance difference test is obtained from the treatment 8. So let's display this significance letter, that means, or these groups B, C, A, B, and A to this box plot. So in order to do that, you have to use, let's create this D, or you can give any name that you want. Then CC. CC means the name of this box plot. So then again, you have to follow by the geom text function. Then data in our case is not K, but instead of K, we have to use the value max here. Then it is followed by the axis, or the aesthetic. So the aesthetics will be the X and the Y. So X is obvious, the fertilizer or the treatment, which is start from the T1 tends to T8. Then the Y, or the Y aesthetic, means it is the maximum value for each treatments plus 0.1, or you can add your number. So for example, you can say 1 or 0.5 or 2, whatever you want. Then the level is equals to the significance letter, then the group. So this will be displayed to the top of the box plot. Then the vertical adjustment is equals to 0. So type this and submit to our studio. Then you will get this significance letter to the box plot. So by this way, you can display the significant letter, or the mean separation, or the honest significance difference test groups into box plot. Let's zoom in. Yes, So there is a jitter, there is the significance letter, there is the p-value, and the level of significance. So we will add the number of sample, the mean value for each treatment to the box plot. So to do that, you have to use the summary SE function, then followed by the data name. So our data name is K. Then the measure variable that we're going to use in this tutorial is the GY. Then the group of the variables is fertilizer or this treatment. So type this and submit to RStudio. Then you will get these samples or this information into the desktop. So we have 6 number of sample, and we have the mean values 2 for treatment 1, 3.17 for treatment 2, and 4.84 for treatment 8. So these two will be displayed to this box plot. How? Follow me. Then D means equivalent to this box plot. Then again, you have to use the geom_text function. Then data is equals to stat name. Stat name means the data that contain the number of samples, standard deviation, standard error, as well as the confidence interval. But what we want here is just to bring the number of sample and the mean value into box plot. So you have to indicate that as equals to stat name. Stat name is what we created here. Then the aesthetics here also, the X is the fertilizer or the treatment. Then this that means, for example, here we are creating for the mean value in order to display the mean value to this box plot. So the Y is equals to 6 means at the point of 6, the mean value of all the treatments, that means all the 8 treatments will be displayed around what? Around this. So group is equals to fur, then the label is equals to round to 2 digits, because as you can see here it is too long, so we reduced into, or we round into 2 significance level. Then you have to indicate also here is 2, or you can add for example, if you want to 3, if you want to 1, you have to do in this way. So type this and submit to RStudio. Then we are expecting their mean values will be displaying to the box plot. Let's see. Yes. So as you can see here, the mean value is displayed around to the point of 6 for each treatment. For the treatment 1 is 2.4, the mean value for treatment 2 is 3.17, the treatment 3 is 2.36, treatment 4 is 2.91, treatment 5 is 3.38, treatment 6 is 4.01, and in with treatment 8 is 4.84 ton per hectare. So in this way you can display the mean value. Then next, let's display the number of samples. So we are expecting 6 sample. So to do that, W is what we created here, or W is equivalent to this box plot. Then you have to use again the geom_text function. Then again also the stats name. Then do it in this way. But the label is equals to what it is here is N. What makes differ from the previous one is what this label is equals to what the grain yield. So in this case, it's what N means our number of sample. At what point are around 6.5, which is we are expecting around here, which is greater than, which is far from the mean value. So type this and submit to RStudio. Then let's see. Yes, so we get the number of sample for the different treatment above the mean value in this way. So again, we have to assign, which it is not it's not clear. We know that it is a mean value and this is a number of sample, but we have to indicate this is n, or we have to give a legend for the number of sample as well as for the mean value. How to do it? Okay, follow me. Then to display the mean value, or to designate or to give a legend for the mean value, so you have to use a boolean, means what we created here. Boolean is equivalent to this, 1, that means a box plot contains significant letter, level of significance, the p-value, the mean value, and the number of sample. So then you have to use the boolean plus the geom text, then axis equals to 0.7. That means if you want to display around here, but for example, if you change this 0.7 to around here, or for example, you have to say 2, which is far from, or it will, or the letter will be enter into the number, or it will be mixed to the number. So you have to use 0.7, 0.4, 0.2. So, and again, y which equals to 6 means the m will be displayed at what? At the 6, because we created before is a 6. So the m, or the legend of the mean value that showed will be displayed at 6 point at the y axis. Let's see it. Yes. As you can see, the mean value is displayed here, so one can easily understand that m stands for the mean value, or you can type mean, so if you want that. So this will be the mean value. So what's left? The number of sample, or we are expecting n here. So let's go for that. Then to do for the number of sample, you have to say here's SCD. SCD means that contain, in addition to the previous box plot, to what it is the legend for the mean value. So again, we have to do for the number of sample. All things are the same, but here you have to type is n. For example, if you want to capital or small, or if you want to add number of sample, you can write in detail. So, and the position of the n will be displayed is equivalent to the position of where the number of sample is found. It's always around 6.5. So type this and submit to RStudio. Then we will get also the number of sample that displayed in the box plot. Yes. So n and m designated for the number of sample and the mean value of the treatment. Furthermore, if you want to give a title for your box plot, so you have to add the GG title, and you can give anything that you want. So for this example, I used width, and the x-axis, or the x-lab means the x-axis. It is a fur. It is an abbreviation, so you should be right in the form of what, in the form of full. That means fertilizer. Again, fertilizer in what? Maybe it is kilogram per hectare. So let's make this G, submit this one, then let's see it. Yes, fertilizer, which is kilogram per hectare, and again also width also displayed here. Yeah. So we have everything in this way. We have ANOVA, or the p-value, the level of significance, the number of sample, the mean value for each treatment, then the jitter, the box plot, even the significance difference later, and also we converted the abbreviation of FER into fertilizer, and also we give the measurement, that means kilogram per hectare. Furthermore, for example, if you want to focus only on one treatment, let's say on the treatment 8, because it is statistically significant, so you have to make all this treatment 1 up to 7 the same color, and you can change the last one. How to do? You have to use the scale color manual, then you have to give the color in this way. So I give here is green, green, green for all. That means starting from treatment 1 to treatment 7, and the last is red. So let's see what it looks like. Yes. Yeah. So all are in a green color, but if you want to give emphasis on the treatment or in one particular trade, so you have to use this syntax. Then obviously treatment 8 is statistically significant, but it is a par with treatment 6, treatment 7, and treatment 5. So in this way you can display the result. Furthermore, for example, here is a treatment 1, 2, 3, 4, 5, 6, 7, and 8. It is written in the number. But if you want to write in the full term, so you have to use here the scale x discrete, then you have to use the break function, and in the break you have to create the vector. So here is t1, t2, t3, t4, t5, t6, t7, t8. T8 you can write all this, and you can convert respectively to that particular conversion. For example, I want to convert the treatment 1 and treatment 2 in a control and pk. So first you have to use the scale as x discrete, then break, then t1, t2, then I'm going to change into what? Control and pk. So you have to use the label function, then control and pk. So type this and submit to our studio. Then as you can see here, the T1 and T2 is removed from the box plot. So you can continue for the rest treatments. In this way. For example, let's add here the treatment 3. Yeah, treatment 3. Then you have to add also here what? Let's say what? BLL. Yeah, BLL or something, or maybe NPSZNB in this fashion. So if you do this, it will be displayed in this way. So do the rest for yourself. Moreover, if you want to remove the x-axis, that means the fertilizer from this one, so you have to use the term, then axis title x is equals to blank or element blank. So this will completely remove the x-axis or the fertilizer kilogram per hectare. So let's do in this way. Yeah, let's do in this way. So we already removed what? The x-axis title. So this is all about today's tutorial, and if you have any question regarding to my tutorial, as usual, don't forget to send through my email address, as well as to comment in the YouTube comment box. And for today, it is all about this, the Boxplot analysis in displaying the p-values, the number of samples, the level of significance, the mean value, along with jitter, and also the significance level. So this is all about today's tutorial. Thank you for watching, and see you soon.